All right, so a rotation of x degrees about a point Q is called the center. Q is the center of rotation. Is a transformation with these two properties. The first property is if you are rotating your point, and that point is on your point of rotation or your center of rotation, it doesn't change. And the second one is, go ahead, Andrew.
For any other point, B, QV prime equals QV, as your angle B, QV prime equals X.
All right, so the distance between your point of rotation and your original figure is the same as the distance between your new point and the center of rotation. So if you look at the picture here, so this distance between Q and your original point V is going to be the same as the distance between Q and V after you rotate it. Okay, and then itself, the number of degrees a figure rotates.
The number of degrees a figure rotates is the angle of rotation.
Awesome, and then Claire, you're a rotation.
A rotation about a point is a rigid motion. You will write the x degrees rotation of triangle UVW about point Q as r degree,
Comma,
Q. Triangle UVW equals triangle U prime V prime W prime.
Okay, so here's the formula for writing a rotation. We use the baby r, and then we do a subscript. We have two items in our subscript. The first item is the angle of rotation, and then the second guy is the point. Then in the parentheses next to that is going to be whatever you're rotating. Sometimes it'll be a line, sometimes it could be a point, sometimes it could be a whole triangle or a whole quadrilateral. But in the parentheses is what you're rotating. And that's going to be equal to whatever your image is. So the primes on your pre-image. Awesome. All right, Jack, let's see how you can do with this. This little statement underneath this information here is not only underlined, it's a bigger font, it's also an exclamation point. So it's got to have a lot of emphasis. It's really important. It's got to have a lot of emphasis. So Jack, go ahead and read this statement to us.
Unless otherwise stated, rotation in this textbook are counterclockwise.
Counterclockwise. So if the clock goes this way, all the rotations will go to the left for this book. So let's go ahead and draw that. For some of you guys, it's possible in today's world for you to get this far in life and not know how to read a clock. If you get stuck, I have a clock there. The red hand is going clockwise. So you can always go, oh, it's opposite of what that little red second hand is doing. All right, so we're going to do 4 rotations here. The first rotation is going to start about point X. So on your guys', I'm going to draw and then erase 4 times. You guys, if you want to do different colors, I have crayons over there, or markers, or if you have colored pencils or a highlighter. You guys might want to use 4 different colors to represent each rotation because it's going to get kind of crazy on your chart. All right, so we're starting at point X, so let's put a dot at X. We're going to go 90 degrees counterclockwise, so that's, and we're going to take AB, the line AB. So A, B. So what I like to do is I'm going to draw kind of a dashed line from our rotation point to our A, and then I'm going to go 90 degrees. 90 degrees from X to A will go X to C. So I'm going to put a dot right next to C, and I'm going to call it A prime. And then if we were to swing B around as well, B would swing all the way over here. So right next to D, I'm going to put B prime. So my A prime, B prime is the same as what? Yeah, it's the same as CD. It's the same as the line CD. So if I were to rotate AB 90 degrees, I'd end up at CD. You guys happy with that? Are you on the right page here?
I didn't have this.
You didn't have a chapter 9 packet? So I'm going to erase these markings so that we can do the next problem. We are going to take Rx. So we're still going to be we're going to have a center of rotation of X, but this time we're going to take Rx. And we're going to rotate it 180 degrees. So that is halfway around a circle. So this R is going to come here, and R prime is going to go right next to the T. And where does X go?
Same spot.
It's going to be same spot. Because remember, when you move a point, that is, or when you rotate a point, and it is the point of origin, it doesn't change. So our new guy is going to be XR, or XT, sorry. So Rx is the same as XT. 180 degrees is halfway around the circle, or if you extend that line out beyond your point of rotation, it just is the resulting figure. Alrighty, everybody feel okay with that? I'm going to erase this again. Different point of origin here now, we have D. So let's find D on our graph. It's this bottom right corner. And we're going to rotate DE, so that's this line here, 90 degrees about point D. So 90 degrees is a little right angle. So it's going to take this E, move it down here. So it's E prime, and D does not change since it's the center of rotation. So our new line is going to be here at CB. Rotations, I like to draw the picture every time. We're going to get 4 different formulas for rotations, and I draw the picture every time even though I have a formula. Okay, triangle AHG this little corner right here is going to be rotated 180 degrees about the point X. So I'm going to go boop, 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 boop. So that distance from K to R has to be preserved when I rotate it 180 degrees. 180 degrees is halfway around the circle. So A goes halfway around the circle, and it's now where the E is. H goes halfway around the circle. So it translates over there, and G goes halfway around the circle. It's here. And then our new rotated figure is going to be E, D, B, triangle.
Maybe C.
Oh, sorry. E, D, C. Why? B. E, D, C. My brain can't get past the B. It's like, right. So the distance between your point of origin and your shape is preserved when you draw your rotation. Okay, so here are the formulas that I was talking about, and we are definitely going to use them. So if you still have your different color pencils out, go ahead and highlight them. So if all these are rotating around the origin. If you find yourself for some reason rotating around not the origin, these formulas are out the window. Don't count. So these are only origin rotations. So if I'm rotating 90 degrees around the origin, I take my original coordinate, x, y, and its new coordinate, I'm going to write these a little bit bigger. So whatever's in the y position, I move it to the front, and I change the sign. Whatever's in the x position, I move it to the back, and I keep the sign. I just move it to the back. Sorry, buddy, get on the back. I'm writing it bigger because when we do our worksheet on 9-3, and I'm helping you, I want to be able to see what the formula is. All right, when we're rotating 180 is one of the easier ones to remember. 180 just puts you in the diagonal quadrant that you originated. So all you're doing is you're taking and you're making you're changing the sign of the x and the y. So you keep the order the same, just change the sign. So if it was negative, then make it positive. If it was positive, then make it negative. All right, 270 is a hard one as well because I just forget which order things go in. We take whatever is in the y coordinate and we put it first, and whatever is in the x coordinate, we put it second, and we change the sign. So y from a negative x.
I feel like the last one should be pretty self-explanatory.
Right? If we're going to rotate something, if we're going to rotate something 360 degrees, we're going to end up back where we started. So there's no change when you're rotating 360. And once again, guys, make sure you draw the picture. All right, we are going to rotate 270 degrees about the origin, this quadrilateral FGHI. So I'm going to make a list. F prime, G prime, H prime, and I prime. So the rule with 270 is that whatever our number is, we're going to put the second one first, the first one second, and change its sign. So F is originally -3, 2. I'm going to take the 2 and I'm going to put it in front. I'm going to take the -3 and make it positive. Then I'm going to graph it, because that's how I do. So G is originally -3, -1. I'm going to take that -1 and put it in the front. Let's take that -3 and make it positive. And then graph it. H prime. Take the -1 and put it in the front, and the -1 and make it positive. So H prime is -1, comma 1. So it's back 1, up 1. Then last but not least, I prime. Take that Y and put it in the front. And what happens to a 0 when you put a negative on front? Is it -0? No, it's just 0. Okay, and then we are going to graph that as well. So our new figure looks like that. Rotated 270 degrees. Remember, 270 is 3/4 the way around the circle. Like a 3/4 turn. Any questions about rotating? Using the formula, finding the image. And just like that, we're now on 9-3. Okay, so for 9-3, we're not doing bookwork. We are doing the worksheet. Yes, please get into your groups.
We're gonna break it. New bedroom. Well, that was me. Danny Bell. How you not saying? It says Danny Bell. Yeah. So, you know. Well, how'd you know before I said that?
5 minutes.
Why'd you say I know? You said it twice. Yeah, that's very thing.
Huh?
Oh, now
If you guys need graph paper,
you didn't.
have some over by the flowers.
Look it up.